In this video, we're going to learn how to solve side angle angle and angle side angle triangles using the law of sines. So I wrote the law of sines up here at the top for easy reference. And the reason why we're looking at side angle angle and angle side angle triangles is in terms of congruent triangles, if you know the side and two angles in that order, and the angle side angle in that order, you have a unique triangle. So we only have one solution. So here I have, for this first one we're going to solve, we have angle A is 40, angle B is 60, and side A is 4. Now you'll see here none of the angles or the sides are labeled, but you can just go ahead and label them wherever you'd like. We know what A is. I like to put my A in the bottom left. My capital B angle at the top. We don't have angle C yet, so we'll find that. But I'm given side A, which is always opposite of angle A. So I'll put 4 here for side A. But I don't know what side C is yet or side B. So my problem to solve this triangle is to find angle C, side B, and side C. So first, I'll start with finding the angle, because given the fact that angle A is 40 degrees and angle B is 60 degrees, then I know that triangles have a total degree amount of 180, and I can use that to find angle C, because I know that 40 degrees plus 60 degrees plus C must equal 180 degrees. So by subtracting 40 and 60 from 180, I'll be left with C is equal to 80 degrees. And thus starts solving the triangle. And I know for sure that it's 80 degrees because of that fact. So now I want to find side B and side C. And I'll use sine of A over A to help me find those sides that I'm missing. So I'll start with sine of A over A is equal to sine of B over B. I'll plug in everything I know. I know that sine of A would be sine of 40 degrees. Side A is 4. And I know that B is 60, so I'll have sine of 60 degrees over side B. And now I want to solve for that variable B in this equation. So I'm going to cross multiply, which will give me B sine of 40 degrees equals 4 sine of 60 degrees. And then I'll divide by sine of 40. And I'll get B is equal to 4 sine of 60 degrees over sine of 40 degrees. And to find out what that side length is, I'm going to use a calculator to find that value. So I have parentheses 4 sine of 60, close parentheses, then close my numerator, parentheses, divided by sine of 40. Now before I hit enter, I'll hit mode. I see I'm still in radian mode, but I need to have this in degree mode. So I'm going to switch that to degree. And I'll hit enter, and I'll get 5.389185421. That's a very long decimal statement, but this problem wants me to round to the nearest hundredth, so it'll be 5.39. So B is approximately 5.39. And now I'm one more side away from solving the triangle. So to find side C, I could use sine of B over B, but I'm going to stick with sine of A over A since that's the information I was given in the problem. I had to round to get B, so I'm going to try to avoid using it. So again, sine of A over A is equal to sine of C over C. So sine of 40 degrees over 4 is equal to sine of 80 degrees over c, and solving it in the same way. Again, I'm looking for that c value. So c would be equal, or sorry, rather, c times sine of 40 degrees when I cross multiply is equal to 4 sine of 80 degrees. Divide by sine of 40, and I'll get that c is equal to 4 sine of 80 degrees over sine of 40 degrees. So slightly different, but it's going to give me a different size for c. So again, I'm going to put 4 sine of 80 this time. And I should still be in degree mode. Divided by sine of 40 degrees. And that gives me 6.13 when I round to the nearest hundredth. And there we have solved the triangle. I mean, we found all the lengths of the sides and all of the angles. So let's look at another problem. Here, this right here is what we refer to as side angle angle, because I was given a side, then followed by two angles. And over here, I'm giving two angles and a side, but when I go to draw these out, A, B, and then side C, I don't have angle C, but I do have side C. So that's angle C. Side C is 5. And angle A is 35 degrees. Angle B is 15 degrees. You'll see here is this angle, side, angle in that order. And this leads to a very unique triangle. So now I'm looking for angle C, and I'm looking for side A and side B. And again, I'm given two angles, so I'm going to find the remaining angle right away. So C would be equal to 180 degrees minus 35 degrees minus 15 degrees. Take away the other two from 180, and that gives me C is equal to 130 degrees. So even though this graph doesn't look like it has an obtuse angle at C, I know from solving this that it is 130 degrees. So this would have been an obtuse angle if I were to redraw it. But now that I have what side C, angle C is, and I have side C, I can now use that to find the values of the other trig functions. So again, I have sine of C over C could be equal to sine of A over A, and sine of C over C could be equal to sine of B over B. So sine of 130 degrees over 5 is equal to sine of 35 degrees over A. Cross multiply, you get A sine of 130 degrees is equal to 5 sine of 35 degrees. So I can say that A is equal to 5 sine of 35 degrees over sine of 130 degrees. Then on the right, I can do the same thing. I can get sine of 130 degrees over 5 is equal to sine of 15 degrees over side B, which I'm also looking for. Cross multiplying, I'll get B times sine of 130 degrees is equal to 5 sine of 15, which means that B by itself, after dividing by 130, sine of 130 is equal to 5 sine of 15 degrees over sine of 130 degrees. And to find out what those side lengths are equal to, I'll plug in these expressions into my calculator. So 5 sine of 35 divided by sine of 130 would be 3.74 for A. And for B, I'll get 5 times sine of 15 degrees divided by sine of 130 degrees. That gives me B is equal to 1.69. Now, whenever you're solving these, another way to know if you are correct is to actually look at the size of the angles versus the length of the sides. The smallest angle should always be across from the smallest side, while the biggest angle should always be across from the biggest side. So over here, 130 is the biggest angle, so 5 should be bigger than my other two answers. And since 15 is my smallest angle, B, which is 1.69, should be less than the other two side lengths. And that is how you solve side angle angle and angle side angle triangles using the law of sines.